Alright, in this video we're going to look at some difficult SAT math questions. So let's get into this first question. It says that the function f is defined by f of x equals 3 to the power of x, and the function g is an increasing linear function. In the xy plane, the graphs of y equals fx and y equals g of x intersect at 2 points, aj and bk, where j is less than k. When g of x is greater than f of x, which of the following must be true? So we got a lot of information there, and we can start by trying to visualize this on a graph. Okay, so let's label our axes x and y. Okay, and we know that we have the function f of x equals 3 to the power of x. So we can begin drawing that. We know it's going to have a point of intersection with the y-axis, right? When x equals 0, we got 3 to the power of 0, which is 1. So we have 0, 1 as 1 point. Okay, we also know when x is equal to 1, we have 3 to the power of 1. So at y equals 3, we will also have an intersect, or a point on our line, right? At x equals 1, y 3. Okay, and we know that an exponential function kind of behaves like this, asymptotal to the across the x-axis to negative infinity. We are told that g of x is an increasing linear function. That means that it is always going to be increasing, and it's a straight line. Okay, so we're just going to draw an arbitrary line, right? It's going to look something like this. This is our g of x. And let's not forget to label our f of x. Okay, and it says that it intersects, g of x intersects f of x at 2 points, a, j, and bk, and we can see that on our graph. So let's also label those. Okay, so this is going to be a, j. Our second point of intersection will be b, j. Or BK, sorry, right? And we know that these are the points because it tells us that K is going to be greater than J, right? Or the Y values of these points. You can see that K on our Y axis is greater than our value of J. So we know we've labeled these correctly. So let's go through our options and see which of the following are true, okay? We've labeled everything we can. X is greater than K, okay? Is this true? We don't necessarily see any of this. Oh, and we're looking at also the, we can see we're only looking at when g of x is greater than f of x, or when that green function that we've drawn is greater than the f of x, or our red function. So we're looking at this point, right? This section, okay? Right? So x is not greater than k at this point. X is not less than j. X is less than j, or x is greater than b. Also does not make sense, but we can see that x is between a and b, right? This is a and this is b. You can see that when g of x is greater than f of x, our x values are between a and b. So D is our correct answer. Okay, let's go to another question. We get the question that gives us two equations of lines. And it says for any real number r, which of the following point lies on the graph of both of the equations? First thing that we should notice, equation number 1, I'll label that one here. Let's label the other equation 2. Well, 2 is just 5 times equation number 1. So these are really the same equation, right? Our solutions to equation 1 are going to be the same solutions for equation 2. Or in other words, if we plug in a point and it satisfies equation 1, it's going to satisfy equation 2 as well. So that's the first thing that we should notice. So to look at this question, there's a couple ways to do it, but one that could be easiest, I would say, is probably just go through. If you only have 4 options, we can just plug in our x value and our y value and see if the left side is going to equal the right side. right? So in other words, 7x minus 9y. If we take option A, well, x is 3r, so we have 7 times 3r, and then minus 9, and our y is 7r minus 13 over 3. We want to see, is this going to equal 39? Because if it equals 39, it satisfies equation 1, and hence will satisfy equation 2 as well. So this gives us 21r minus, we can see that we have a 9 and we have a 3, so we can just do 9 divided by 3, right? Which is just going to be 3. And we are left with times 7r minus 13. Expanding that bracket, we have 21r minus 7 times 3 is 21r. Negative times a negative is a positive, and we get plus 39. Our 21r's cancel out, and we're left with 39. So we got lucky. It's actually the first option is our correct one, right? We can see that since 7x minus 9y, when we substituted in that point from option A, it was equal to our right-hand side of 39. Since equation 2 is just a multiple of equation 1, it will satisfy both equations. Great. Let's look at the next question. In the given equation, k is a positive constant. The product of the solutions to the equation is 154. What is the value of k? So this is just an algebra question, right? It's telling us that the product of the solutions is equal to 154. I can see 3 different x values here. We're in our factored form, and there's 3 different factors here. So I know that there's going to be 3 different solutions. And it's telling us in the question that the product of the solutions, so the multiplication of our first solution times our second solution times our third, will be equal to 154. So that's all that we're given. Okay, so let's try to find the solutions. So first off, we know that this is equal to 0, so we can multiply both sides by 5 over 3. So that's going to give us, it's going to cancel out our 3/5 on the left side, and it's multiplied by 0 on the right side, so that will remain 0. We now have 5x plus 11, and we have x plus square root of 5k plus 10 times x minus square root of 5k plus 10 equals 0. Okay? What you should notice is that this is actually a difference of squares, right? Our second and our third term here, right? This is the expanded form of x squared minus, let's call it b squared, right? Because we know x squared minus b squared is going to be equal to x minus b times x plus b, right? We can see here that our x squared would be, our first term is still just going to be our variable x, right? X squared has been expanded to x and x. Our second term, right, our b, right? We can see that our b squared would just be square root of 5k plus 10 times the square root of 5k plus 10, right? So we can see that b squared is 5k plus 10, right? Our square roots are going to cancel each other out, right? So what we can see here now, we can simplify this to just x squared minus, and our b squared we just found is 5k plus 10, and make sure you don't forget the brackets there. Okay. Now we can see that we can solve for our solutions quite easily. Our first solution is negative 11 over 5. This is just setting our factors equal to 0. Our next solutions, well, we'll get, setting our second term equal to 0, we will get x squared is equal to 5k plus 10, which means that one solution will be the square root of 5k plus 10. And our third solution will be the negative square root of 5k plus 10. Right? That's just taking the square root of both sides. Remember, we have a plus and a minus. Okay? Finally, we know that negative 11 times 5 times negative square root of 5k plus 10 times the square root of 5k plus 10 is equal to, and what does it tell us? It's 154. Okay, now we can just begin to simplify. Okay, we can see that we get our negatives cancel out. Okay, let's move this down. Our negatives cancel out. We get 11/5 times, and now we are left with 5k plus 10. And yeah, that's equal to 154, right? Because our square roots have canceled out, our negatives have turned to a positive. Okay, and now it's just a matter of solving for k, right? So multiply both sides by 5 over 11. We get 5k plus 10 is equal to 5 over 11 times 154. And then we can subtract 10 from both sides and divide by 5. So k would be equal to 12 if you compute that. Okay, let's go to our next question. Okay, in the figure, BC is the diameter of the circle if the length of BC is equal to 132 and the length of AB is equal to the square root of 363, then what's the value of BC over BD? So what we want to notice here is that we have various different triangles, and some of these triangles share the same angle, right? Okay, we also know that ABC, since BC is the diameter, it passes through the center of the circle. Okay, so since A, B, and C, right, this triangle ABC, okay, it shares the same angle as the triangle ABD, right? This is, and we can see our triangle ABC, right? And it's got a right angle right there, and we'll call this angle our angle theta. Okay, so what we know, okay, we know that the ratio of an angle from triangle ABC to a triangle that shares this angle would have the same ratio. So, for example, the cosine of theta we know is the adjacent over the hypotenuse, right? And the adjacent angle for triangle ABC is AB because it's adjacent to our angle theta, and it's got a hypotenuse of BC, AB over BC. Okay? And we know that there's another triangle that shares this angle, so its cosine should also have the same value. Okay, and let's draw this one now in green, right? You can see that triangle ABD, since it shares that angle theta, right? It's going to have the same cosine. So the cosine of this triangle, well, the adjacent side to theta would be BD, and the hypotenuse would now be AB. Okay? And let's just label this as triangle ABC, and this is triangle ABD. Okay? We are told in the question that AB is square root of 363 So we get square root of 363 divided by BC, which is 132. And now we say this is equal to, okay, well, BD, we don't know. But AB we know is square root of 363. So we get BD is equal to, now just solving this, multiply both sides by the square root of 363. We get 363 over 132. Okay, and the question is asking us, what is the value of BC divided by BD? And we have both of these actually, right? So BC over BD. Well, BC is 132, right? And BD is 363 over 132, right? When we have a fraction in our denominator, remember we take the denominator in the denominator and we multiply it by the numerator, right? Or because we got 132 divided by 363 over 132, right? And this is, let me zoom in here. And this is just 132 times, we flip our second fraction, right? And we get 132 over 363. Putting this into your calculator, you should end up with 48, I believe. Great. Okay, let's move on to, I think, our last question here. Okay, given the quadratic function below, and it has factors in the form of, as it gives us, if A, B, C, and D are integers, then what is the smallest possible value of A times B? Okay, well, we're given a quadratic function, okay, and it's of the 4th degree, right? And it looks like we want to turn this into something a bit more friendly looking. And we can do that by a quick little substitution. So let's just choose A, capital A, and you could choose whatever variable you want. Let's let that be equal to x squared. If that's x squared, then that means that A squared would just be x squared squared, which is x to the power of 4. So that means that 54x cubed, or x to the 4, plus 219x squared plus 105, well, that's going to be equal to 54a squared plus 219a plus 105. And now you can see that this is just like a more friendly looking quadratic that we're more used to looking at, right? And we can solve for our solutions of this, or we can solve for values of a as the quadratic formula, right? So we know that a is going to be negative b, negative 219, plus or minus the square root of b squared, which is 219 squared, minus 4 times a, which is 54, c, which is 105, all divided by 2a, or 2 times 54. Okay, solving for this, you're going to get a is negative 7 over 2, or a is equal to negative 9/5, I believe. Yeah, I'm going off of what I remember, so yeah, should be something like this. Actually, let me just double check. Great, so our second root was actually negative 5/9. Okay, we can notice now, okay, that in our factored form, right, this would be 2a plus 7, and this root would be 9a plus 5, right? And remember what a was. A was just x squared. So we would have 2x squared plus 7, or 9x squared plus 5, right? And let's look at let's look at the form we had, right? We had k times ax squared plus b plus cx squared plus d, right? So we know that both of these roots, okay, if we had a k out front here, right, either this could be ax squared plus b, or this could be ax squared plus b. So if either of them are ax squared plus b, we're looking for the smallest possible product, right, of ab. So ab could either be 2 times 7, which is 14, or ab could be 9 times 5, which is 45. So since 14 is less than 45, it's asking for our smallest possible value of a times b. So therefore, our smallest possible value would be 14. And that's it.